Hi everybody, I recently got these new chips in the mail, the MAX9918 high side bi-directional current sensor, and I thought I'd do a quick video showing its operation. It's a really easy chip to use. You only need basically one single component, two if you count the current shunt, a gain setting set of resistors here, and a current shunt here. On my demonstration circuit, I've just put a potentiometer here so I can turn it to adjust the gain. The idea behind these kind of chips is they allow you to convert a current across a sense resistor to an output voltage, which is useful if you want to measure current with your microcontroller or Arduino or something like that, because you can connect the output voltage directly to the analog input of your microcontroller. The reason you generally need a special chip for this is because this input will be at the right up against the positive rail, so most op amps will generally not be able to have an input all the way up to the positive rail or all the way down to ground, and most op amps will generally have some error if the difference in voltage is very small, but these chips are specialized to handle those kind of conditions, so they're usually sold as current sense amplifiers. So on my circuit here, I've got this shunt that I bought from eBay, which is 7.5 milliohms, and I've put a small multi-turn potentiometer in here, which allows me to adjust the gain. This multimeter is going to show the current through the load, and this is going to show the output voltage of the current sense amplifier. So what I've done is I've turned the potentiometer to try to get 10 millivolts per milliamp, I think. Let me just check that. So we'll connect our power to the load, and we've got 400 milliamps but 40 millivolts output, which is cool. And you can see if I get in here and adjust the gain, we can change what output voltage we get. So what we do is we try to turn it until it matches as close as we can get it. There we go. So we've wound it until we've basically got 10 millivolts per 100 milliamps. And just to show that that is working, let's get in here and adjust our current limit. So we've got 1.22 amps and 127 millivolts. So you see we've got a little bit of error in there, but it's not too bad. I found actually the error tends to be worse on the low side. So if we go right down to quite a small current, 0.0, so 56 milliamps, so we should actually be seeing 5.6 there, but we're not. It's kind of out, but you'll see that as we get higher, the error reduces. 135 is reading as 1.2, but once we get up to the couple hundred milliamp range, the error is quite low. That might be due to my shunt being a little bit too low resistance. I imagine that if you used a high resistance shunt, you'd get more accuracy at the smaller current ranges. If you're using a microcontroller to read the current, you might be able to compensate for that error a little bit in software. But overall, not a bad chip. Costs about $3. Really easy to use. Another interesting thing about it is the common mode input range that you're measuring, and by common mode I mean the differences between these. I mean the maximum value that this or this can be relative to ground can be 25 volts below ground up to 75 volts above, so you could use it for inductive loads or even loads where the current goes backwards through the sense resistor. An interesting attribute this amplifier has is if you set reference into half the rail voltage, halfway between VCC and ground, output will actually go above and below ref depending on the direction of the current. But if you set ref into ground, it turns it into a unidirectional sense. So far, pretty promising chip. Little bit on the expensive side, nice and easy to use and configure, so maybe worth some consideration if you want to do some high side current sensing. Have a good one.